Here's the solutions to the sample problems for the final exam for Math 2413, Calculus 1. And as you can see here, problem number 1 is a limit question. It's a one-sided limit with the exponent being plus. That means coming to the right. So you're only looking at this graph as it's moving right to left, like so. And it's approaching right along there, right there at that hole, which that hole would have a value of 3. So the answer would be 3. Had this been the minus limit, which you could have both those questions on the final in the same problem maybe, but it would be coming from left to right, and then it would be approaching 4. So that would have been the answer, but 3 is correct, coming from the right. Problem 2. Now this is a limit that if you plug in, first thing you want to do on a limit algebraic is plug in the number and see what it produces. If it gets a real number answer, then you're done. But if you put 3 in here, you're going to get 0 over 0. And these kind of polynomial problems generally lead to factor and cancel situations. So you can see I factored the numerator into x plus 5 and x minus 3, and then factored the denominator, difference of two squares, x plus 3, x minus 3, and you see the x minus 3's would then cancel, and then you just reinsert the 3 back in for x. So you have 3 plus 5 over 3 plus 3, which is 8 over 6, which of course reduces to 4/3. Now the next one's also a one-sided limit, minus coming from left to right. You could put this in, put the number in, and you get 3 over 0, or anything over 0 means we're going to get one of the infinities for this answer. But you could plug the number in first to see if it works, because you may remember the rule about limits that if the regular limit that I call it, when it doesn't have the plus or minus up there, if that has a certain value, that means both the one-sided limits will also be that value. In other words, the regular limit doesn't exist if those two values are different. Scroll back up here for a second, I'll show you what I mean. So you see this first problem had an answer for plus and minus, but if we just would have said x approaches 1 without the plus or minus, the answer would have been does not exist, because they're not converging at the same location from both sides. And this one, the fact that you put 3 in there, that's 4/3. That means the minus or the plus limit would also be 4/3. They would have to all equal that value. So what I would do here, you could put a graph in your calculator if you want to, but I just made sure I picked values on the correct side of 3, whether it was plus or minus. In this case, it's negative, so you have to approach it from the left to the right. So you see I have 2.9, 2.99, 2.999, and they're getting smaller and smaller and smaller, heading toward negative infinity. So that's why negative infinity would be the answer. But you could also graph it and look at it that way too. You just have to pay attention to which side it's coming from based on the minus or plus. Okay. Find all the values where the function is discontinuous. Well, one of the obvious type things you're looking for in discontinuities is anything that causes division by 0. Probably the primary thing for polynomial type functions, and we don't care about the numerator. So the fact that 0 makes that numerator 0, we don't care about that. It's the two values that make that denominator 0. And you can see I came down here, I solved for each one of those separately. 5/8, negative 9/2. I just wrote them as not equal there. You don't have to worry about that too much. That's just saying those are the points where it's not continuous, which is the same thing as saying that means they are discontinuous. So you won't be tricked with something like that on a final. But so it's 5/8 and negative 9/2, but not 0. Okay, average rate of change is essentially a slope calculation, because that's one of the things we've learned, that average rate of change is always between 2 points, and it's a slope calculation, whereas instantaneous rate of change is the derivative at a single point. So this is real straightforward. It's just basically a slope, y2 minus y1 over m2 minus m1. I just have it written in function notation, but that's okay. Y and f of x, of course, are the same thing. So So you take f of 7, put 7 in there, you're going to get 84. Put 2 in here, 4 plus 10 is 14. Then, of course, 7 minus 2 would be 5. So you get 70, subtract on top, divided by 5. So the average rate of change on that interval will be 14. Now, this one, number 6. Find the instantaneous rate of change for the function x squared plus 7x at x equals 2. So that's what I was just saying in the last problem. Instantaneous rate of change means derivative. So we'll just find the derivative, and then we'll plug in the value 2. So this one's really easy. So the derivative of x squared plus 7x would be 2x plus 7. F prime of 2 equals 11. Let's see. One thing I want to mention, if you are taking a course where you're, handwriting all your work, and your answers, and it depends on if you take Cal 2, whatever instructor, handwritten, you might want you, because I know I do, I like for people to write derivative notation. In other words, if you're finding the derivative, I would always penalize if somebody just wrote, if they only wrote, 2x plus 7, just that only without the f prime part, I would take off points for that. So, using proper notation's always a good idea. But you could just, check that out with your instructor, see how they want, whatever they want, what counts. But I'm a little bit picky about that. Okay, slope of a tangent line at a given value of the variable. Okay, that's instantaneous rate of change is the same thing as slope of a tangent line. They're both implying you want the derivative and you want it at a single point. Now what I did here is I'm indicating that 9 divided by x is 9x to the negative 1, just because it would be kind of a wasted effort to do a quotient rule there when you could just bring it up and do the power rule. I don't know, but if you do a quotient rule, it's not wrong, and it seems kind of pointless. So the derivative of 3x would be 3, and you bring down the negative 1, makes it negative 9, makes that x to the negative 2, and then now I plug the 4 in there. So see, now I plug the 4, then I drop the x back down. So it's 3 minus 9 divided by 4 squared. So I just got a common denominator, which obviously you can do all this in the calculator. And I end up with 39 over 16. All right, so that's not too bad. Let's see what we got here. Number 8. Find any values of x for which, this is kind of blurred. You can see this on your regular file, but whenever I convert it over to this format, it tends to get messed up. But you'll see it clearly on the regular file where f prime is not defined. Okay, the main thing you're looking for in the derivative is not defined. It's not defined at 3 things. Endpoints. The function has a closed interval, or it can be closed on either side. It's not defined at an endpoint, which is not the problem here, because the arrows imply, forever and ever. It's not defined at discontinuities, whether it be asymptotes or holes or anything like that. And the third one is it's not derivative. It's not defined at sharp points. And that's kind of what we got going on here. If I had this kind of problem on a test, I think I would use a better looking graph than this. But that's why I'm saying 2 is the only value which the derivative is not defined, because there's a sharp point there. All right, I wouldn't want to try to trick somebody with that. Number 9, same question as number 8. You see, we have a sharp, a single point by itself, not functions. No, it's a discontinuity. It's not connecting there at 0, so there'd be one of them. And that's kind of hard to see. Once again, the quality of this graph's not the best, but there's a hole right there at 3. So it's the endpoint here, the 3, so 0 and 3 would be the 2 values. Number 10. All right. Looks like I didn't show a lot of work for this one, but I'll go ahead and explain it. Similar to the last problem, I would have rewritten 8 over x as 8x to the negative 1. So I'd bring down the exponent, -8, you subtract 1 makes it -2. And then it's just a matter of knowing that the derivative of secant is secant tan. So you wouldn't need to know that. So therefore it's negative. So you see the answers have to drop it back to positive exponents. So it's -8 divided by x squared. I personally don't mind negative exponents, but answer choices usually aren't that way. So plus 6 sec x tan x. All right, number 11. What points with this particular function with the slope have a tangent line equal to 6? All right, well, it'd be hard to kind of graph this and see where the slope equals 6 because we're trying to sort of find something like this. Try to draw this. It won't be very good because it's freehand, but and then you're trying to find basically whatever value you want. In this case, say that was a 6. You can find one right there, up here. Oop, that's not very good with the mouse, is it? Well, anyway, all right. Wouldn't look that terrible. Well, anyway, you don't need a graph to worry about this anyway. Just solve it. So if the slope of the tangent line is going to be 6, that means anywhere for x. Now they're asking for the coordinates, so we'll go back and get the y also, which is just a matter of plugging it back in the original equation. Basically setting the derivative equal to 6 to see what values, if any. Well, you can tell by the answer choices, it definitely has answers here. So, but in theory, it could be none. So let's see, that's an easy derivative. 6x squared minus 18x minus 18. We're setting that equal to 6. All right, so that's quadratic, so we have to let it set equal to 0. So I'll move the 6 over to get a set equal to 0. And let's see. And I factored out a 6. So -18 and -6, I sort of skipped a step there. Make that -24 together. So when you factor out a 6, that just leaves an x squared, a minus 3x, and we'll leave a -4. So 6 times the -4 would give you the -24 for these two. Okay, then I just conveniently divide it by the 6, because 0 divided by 6 will still be 0. So that's the beauty of solving equations set equal to 0. One thing to keep in mind to help you in general, while I'm thinking about it, students make this mistake a lot, is you don't ever divide a variable. Like, let's say there was an x outside this parentheses, you would not divide by x. That's wrong because you would lose one of the solutions, because x equals 0 would be one of the solutions. So never, ever, ever, whether it's algebraic or trig, don't ever divide by the trig variable like sine x or cos x. Never divide a variable when you're solving an equation. All right, so numbers though, no problem. Okay, so that factored into these two, x minus 4, x plus 1. So it's -1 and 4. Well, this particular problem, but who knows if this was on the test, but you actually don't have to go back and get the y's because C is the only answer of these 4 that has the -1 and 4 both. You see that D has the -1 but not the 4, B has the 4 but not the 0, and A is not even close at all. But if you did plug in, I wrote them right there, so put -1 back into the original, you get 7, put 4 in there,